Finding natural domains is a subject that frequently gives algebra students trouble. But like so many things in mathematics, I really think if you just take it slowly and don't try to take shortcuts or skip steps, you're going to be okay. So suppose we have a function f of x, and we want its natural domain. Well, so far, sorry, I did not mean to do that. So far, there are two ways to not be in the natural domain. We cannot divide by 0. And because our output has to be real here, we cannot take the square roots of negative numbers. So finding the natural domain is basically just following a checklist. We're going to look at any square roots we have and find the inputs that make them, I guess I should say, make the number under the radical sign, but positive. Then we look at any fractions and find all the values that make the denominator 0. And then the natural domain is all the numbers in the first group minus the numbers in the second group. So I think everything in math becomes clearer when you do an example. Let's find the natural domain of the following function. The square root of x plus 2 divided by x minus 1. So we'll start by looking for any square roots, and we do have a square root, this one here, and we need whatever we have under the square root to not be negative, so that we don't have any imaginary numbers. And this, I suppose, could potentially be difficult if we had something complicated under the square root and it gave us a difficult to solve inequality. But this we can deal with easily enough. Just subtract 2 from both sides. So x is the numbers greater than or equal to 2, except that x minus 1 is not allowed to be 0. So x is not allowed to be 1. So the natural domain is all the numbers greater than or equal to negative 2, except for 1. If we now wanted to express this, I mean, this is the solution. This is the natural domain. If we wanted to express it in interval notation, there are a few ways we could do this. The first is, sorry, I know the light's kind of weird. There are a few ways we could do this. The classic way would be this. We want all the numbers greater than or equal to negative 2, but we want to include 1. Sorry, that was the opposite of what I meant to say. We do not want to include 1. This breaks this segment or array of the number line into 2 pieces. There are the numbers between negative 2 and 1. And there are the numbers greater than 1. Each of these pieces can be represented as an interval And then we put them together using the union. My preferred notation for this kind of thing is a little more rough and ready, or maybe just concise. In set theory, this backslash tells you to exclude whatever comes after the backslash. So we want all the numbers between a -2 and infinity, but we want to exclude the number 1. If we put it in curly braces, if we wanted to exclude more than one number, we'd just list them. 1, whatever the other number we wanted to get rid of is. And that's the natural domain. And when people have trouble with the natural domain, it's because they do not follow these steps. And I mean, I guess that's sort of trivially true for any mathematical problem. If you get the wrong answer, you followed some step incorrectly. But I feel like it's especially true of the natural domain. Like, I'll give a homework problem. Find the natural domain of f of x equals x divided by x minus 1. And I will always get a homework back with this as the solution. And where is this coming from? Well, the student has some idea that division that involves 0 causes problems. So the student has some idea that x shouldn't be 0, which is incorrect, but then instead of just writing x isn't 0, they forget all about the negative numbers and give me this instead. Whereas if you just follow these steps, it's like a 10-second problem. You can't take the square root of any negative number. Well, there are no square roots. So we start with the entire real number line. Look at any fractions, find the values that make the denominator 0. X equals 1. makes the denominator 0. So we're starting with the entire real number line because there are no real numbers that give you negative square roots. And then we get rid of the values that make the denominator 0. And there's the natural domain. So it's really important not to go off book on these problems. When students start trying to do anything other than this algorithm, it almost always leads to disaster.